Hi, my name is Dai Matsuzaka, and today we're going to be going through Chapter 4.1, Quadratic Equations. So, for a given quadratic equation, the form cx plus a times dx plus b is equal to 0 is the factored form of the equation, where c, a, d, b are all coefficients, or just constants, and they are just integers. So, if you recall back to the definition of linear equations, we had something like ax plus b, right? So, we had something like this, right? This is linear. The degree is just 1, right? But now we're talking about equations that look something like this. Something like ax squared plus bx plus c. Now this is a completely different mathematical thing, right? It's a polynomial, but its degree, it's different. So, when we're given the factored form of the quadratic equation, the solution to it, what x is, the identity is actually really easy to find, right? So if you think about what we have on the previous page right here, cx plus a, dx plus b equals 0. Because this is a multiplication of two things, so if we multiply thing a with b and it equals 0, this means that either a is equal to 0, 0, or b is equal to 0. So then we just have two possible answers. We have cx plus a is equal to 0, or dx plus b is equal to 0, right? And then it's just a simple algebra at that point. You have x is equal to negative a over c, or x is equal to negative b over d. Now, if we assume that c and d are equal to 1, we have that x is more simple than that, right? So if c and d are equal to 1, then x plus a is just equal to 0, so x is equal to negative a. As you can see from here, you can just generalize with this. Now, we define the following equation. So we want to approach the equation can be something like this. 3x squared plus 15x equal minus 12. Right? Again, the degree of this function, this equation is 2, right? Because your highest power on your x, the variable, is 2. So it's a quadratic equation. Now, we want to approach the factored form by first simplifying this equation. Dividing both sides by 3, we have the following, which is x squared plus 5x equal negative 4. Right? And then now we want to move negative 4 to the other side so we can equate this to 0. So then we have x squared plus 5x plus 4 equals 0 right here with this equation. So the equation 3x squared plus 15, was it 15? Yeah, 15x equal minus 12 can be simplified all the way to here and equated to 0. X squared plus 5x plus 4 equals 0. But notice that from here, how do we proceed, right? This is actually very difficult. It's a difficult question. How do you get it into the factored form? And that's an important step for us. So we're going to take a bit of time doing this. So if you recall the format of the factored form, it's cx plus a times dx plus b equals 0, right? So let's try to find what this actually looks like when it's expanded out, because this is expanded out, right? So then you get cd, right? Multiply each term. So you get cdx squared plus bcx plus, we multiply the second term with the first term, we get a dx, and the second term with the second term plus ab, which is equal to 0. Now we can group these things together, right? And so we can claim that given this factored form, we have cdx squared plus bc plus ad x plus ab is all equal to 0. Now, already at this point, we can deduce a couple things. If you look at the original equation, x squared plus 5x plus 4, what is the coefficient on x squared? Well, it's 1. So we can just assume that c and d are equal to 1. So we assume that c and d are equal to 1, we have x plus a times x plus b is equal to 0. Now, if you expand this out, we have x squared plus a plus b x plus a times b equal 0. Now this is something that we can actually look at and maybe draw a connection with the initial equation. Well, it's the fact that a plus b must be equal to 5, right? Because 5x. 5 is a coefficient. A plus b is a coefficient of x. So you have this equation. A plus b is equal to 5 necessarily. And a times b must be equal to 4. So what does this come to? Well, it comes down to a system of equations. We need to find two numbers such that the addition of it is equal to 5, the coefficient on x, and the multiplication is equal to 4, which is a constant that you're adding at the end of the equation. Now, quickly, you can find some numbers, right? What are the numbers that add up to 5 and multiply to 4? Well, numbers that add up to 5, right? Think you can only have you can have positive and negative values. But one such value is a is equal to 1, b is equal to 4, right? And this, you can quickly justify, satisfies both cases. And because it satisfies both the equations, you know that this is a valid solution. So you can actually rewrite x squared plus 5x plus 4 as x plus 4 and x plus 1 equal to 0. Now that you're given this form, right, we can find the solution to x. That was from the previous example. X is equal to negative 4 and x is equal to negative 1. These two are the valid solutions to this equation right here. Now, we want to be able to find a quadratic equation for all of these cases, right? And in the previous example right here, we were likely to come across a equation, system of equations, such that it is simple enough for us to be able to find quickly, right? A times b equal 4, a plus b is equal to 5. Well, it's actually quite simple because we can just find all the numbers that multiply up to 4 and see if it adds up to 5. So ab, well, 1 times 4 is a possible one. 2 times 2 is possible. You can do both negative 1, negative 4, and both negative 2, negative 2. These are the only solutions possible for a and b. A, b, right? And which ones add up to 5? Well, only these guys. So it's just a process of elimination. It's very quick, as long as you get this identity here. But sometimes it's not that simple. What if a and b are really large numbers, right? That makes it really difficult. But in that case, we have this formula where the x, so if x is in the form ax squared plus bx plus c, this is equal to 0, then you can find the solutions to this equation, which is of the following form, which is x is equal to negative b plus minus square root b squared minus 4ac over 2a. Okay? This is a formula that works for every quadratic equation, and we will do a derivation of this formula later. So luckily, in this case, we have a simple enough system of equations such that we can just write out all the possible cases. So we have 1, 4, 2, 2, negative 1, negative 4, negative 2, negative 2. These are all the cases in which a times b is equal to 4, and a, b are integers, right? And there's no other case in which a times b is equal to 4. So then it's just a process of elimination. Which ones add up to 5? Well, 2 plus 2 is not 5. The negatives, if you add negatives together, you don't get a positive number, so that's already out of the question. So 1 and 4 must be the only one. And it works. So that's great. But what if a and b, like, say a times b is equal to, like, 10,000, and a plus b is equal to 792 or something, right? Then there's so many possibilities. How can you possibly check them all by hand? And that's when we make use of a basically a formula for the quadratic equation. So given ax squared plus bx plus c equals 0, so just a general form of the quadratic equation, we have that the potential solutions to this is going to be of the form b plus minus negative b plus minus square root of b squared minus 4ac all over 2 times a. And this might seem very confusing and hard to see intuitively why this is the case, but we will prove this using the something called completing the square formula. Now, note that when we say plus minus, it means that there's actually two solutions. One where it's just the plus, one where it's the negative, right? So technically, we have one solution where it's minus b plus square root over 2a. There's one solution where it's minus b minus square root b squared minus 4ac over 2a. Now, let's try to prove this. So you're going to be looking at something in the next video about completing the square. For this time, just assume that this works. So we take ax squared plus bx plus c equals 0, such that a is greater than 0. So we can do this because we equated to 0, right? So if we have some like general equation like minus 2x squared plus 4x plus minus 5 equals 0, we can just quickly multiply both sides by -1 to get a to be positive. So we make a positive in this process, in this proof here. Okay. Plus bx plus c equals 0. And completing the square is basically just an equivalent way to rewrite this general equation into the form as follows. And it goes like this. Square root of ax plus b over 2 square root of a to the power of 2 minus b squared over 4 plus c. This is actually equal to this guy. Now that we have this form, we can actually continue with the simplification. And that is done by doing a just some simple algebra, actually. So if this is equal to 0, then we know that we just want to isolate for x, right? So in that case, you just have, here, I'll erase this. We have that square root of a, x plus b over 2 square root of a to the power of 2 is equal to b squared 4a minus c. And this is also equivalent to b squared minus 4ac over 4a. Now, continuing from that point on, we take the square of the whole thing, right? So that we can get x to be isolated. We want to take the square root of this and the square root of this. Now we have the form ax plus b over 2 square root of a equal to plus minus. This exists because we took the square root of a square, which leaves us with a plus minus. The rules of algebra can be found in chapter 1 later. Now, b squared minus 4ac over 4a, right? This is what we had previously, and we're just square rooting the whole thing. As I said, plus minus comes from the fact that we're actually taking the square root of something that is squared, right? The power of 2. Now that we have that, we can actually simplify this even more, right? We want to isolate for x, and we're pretty close, right? We already have square root of ax plus something, so minus that, right? We have plus b over 2 square root of a. So if you subtract that from this side, we get square root of ax, which is equal to plus minus b squared minus 4ac all over 2 square root of a minus b over 2 root a, which is also just equivalent to minus b plus minus square root b squared minus 4ac divided by 2 square root of a. Now I think you can see where this is going. If you just divide both sides by square root of a, you can isolate for x and arrive at the formula, which is simply x is equal to minus b plus minus b squared minus 4ac over 2a. You don't need to know the derivation of this, but you do need to memorize this formula and use it when necessary. There is going to be questions that is going to be very difficult for you to just factor using the methods that we discussed prior, where you're just basically substituting for possible values of the factored form. I'll see you in the next video.